9.2 Conditions for Parallelograms. In this lesson, we're going to learn how to prove the following theorems about parallelograms. And those are that opposite sides are congruent, opposite angles are congruent, and the diagonals of a parallelogram bisect each other, and conversely, rectangles are parallelograms with congruent diagonals. So to start off, we're going to be talking about proving the opposite sides are congruent for parallelograms. And the theorem that we're going to be looking at is Theorem 1. So for Theorem 1, if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So let me kind of break this up into two pieces. We need two things. We need to know that the opposite sides are parallel. So actually let's look at EF and HG. If EF and HG are parallel, and if EF and HG are congruent, then that proves that this is a parallelogram. So remember, the notation for parallel is an arrow. So these arrows signify that these two lines are parallel, and a notation for congruency is these marks, these tick marks. Okay, so next we're going to look at the second theorem, which talks about opposite sides again. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this theorem, if we know that the opposite sides are congruent, if this side and this side are congruent, and if this side and this side are congruent, then that means that this is a parallelogram. So notice that in this theorem, we do not know anything about parallel sides as we did in Theorem 1. So Theorem 2 focuses just on opposite congruent sides. Next, we're going to look at opposite angle of parallelograms. So Theorem 3 states if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And opposite angles are angles that are on opposite sides of the parallelogram. So an example would be angle HEF, which is this angle here, and angle HGF. HGF, which is that angle there. Remember that the middle letter tells us where the angle is located. So HEF, HGF, and then EHG, so this angle, and EFG are also congruent. So opposite angles are congruent, opposite angles are congruent. And the last theorem that we're going to look at is proving bisecting diagonals of parallelograms. So if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And remember that a diagonal is a line that goes from one side of the parallelogram to the other side. So this is a diagonal line. This is another diagonal line. And bisect means that they cross so that each piece is congruent to each other. So that means that this piece is congruent to this piece, and this piece is congruent to this piece. So we're going to be using these theorems to answer some questions or to prove that a figure, a quadrilateral, is a parallelogram in the next couple pages. But let's kind of just review Theorem 2, 3, and 4. And let's start with Theorem 2. According to Theorem 2, label the parallelogram with appropriate tick mark. So remember, Theorem 2 tells us that opposite sides are congruent, and we're going to be using tick marks. So AB is congruent to DC, and AD is congruent to BC. Then, according to Theorem 3, label the parallelogram appropriately. So Theorem 3 talked about opposite angles. So the opposite angles are angle A and angle C. If these two are congruent, and if angle D and angle B are congruent, then this proves this is a parallelogram. Now, I just want to recap that opposite angles are A and C, D and B. What are angle A and B called? So they're not opposite angles. These are actually supplementary angles. Angle A and angle B actually add up to 180 degrees. So if we knew one of these angles, we could actually find this angle, and then we could actually find all angles in the parallelogram. But we'll actually do an example on that later. And then Theorem 4 talked about diagonals. So let's draw a diagonal AC, and let's draw a diagonal BD. And Theorem 4 tells us that the diagonals bisect each other, meaning that this piece is congruent to this piece, and this piece is congruent to this piece. So in this next part of lesson 9.2, we're going to verify if figures are parallelograms. They actually give us an example that's already completed for us. However, there is actually a typo in that they don't actually give us the parallelogram figure that they're supposed to give us. So what we're going to do is we're just going to skip these examples, and then we're going to just create our own examples on the Your Turn problems at the bottom of page 23. Okay, so the directions tell us to show that each quadrilateral is a parallelogram for the given values of the variables, and they tell us that step 2 is completed. We'll get to step 2 in a little bit, but there's a couple things that we need to know before. The first thing is that Z is equal to 11, W is equal to 4.5. And then we have different angles. We have different expressions for different angles. So angle F is 9Z plus 19, and then we have the other ones here. So what we are doing in this lesson is we are finding out what angle F is and finding out what angle H is by plugging in 11 in for Z. So angle F is equal to 9Z, but Z is 11, plus 19. Which becomes 99 plus 19, and that becomes 118 degrees. So angle F is 118 degrees. Then we do the same thing for angle H. Angle H is 11Z, so 11 times 11 minus 3. And that is 121 minus 3, and that is 118 degrees. So notice that angle F is congruent to angle H because they both equal 118 degrees. And that's what we're looking for. If angle F and angle H are congruent, if these two angles are congruent, that's a good indication that this entire object is a parallelogram. So let's look at step 2. They were comparing angle E and angle G. And for these expressions, what they plugged in was W, which was 4.5. And you can kind of see the algebra here. They plugged in 4.5 for W, and again 4.5 for W, and they ended up getting that angle E is 62 degrees and angle G is 62 degrees. And we notice that E and G are congruent to each other as well. So to wrap this problem up, the measure of angle F is equal to the measure of angle H. And the measure of angle E is equal to the measure of angle G. So EFGH is a parallelogram. Okay, so we are on the top of page 24. In these problems, what we're doing is we're evaluating the letters that they give us into the expression. So the first thing that we are doing is, let's look at the sides. We have QP and RS. Let's find out what QP is, and let's find out what RS is. So QP is equal to 7A, and A is 2.4. 7 times 2.4 is 16.8. So QP equals 16.8. Then we could try RS. So RS is equal to 2A, so 2 times 2.4 plus 12, and that is 4.8 plus 12, and that becomes 16.8. So one thing that we notice is that these opposite sides are congruent to each other because they're both 16.8. Next, we need to look at these angles by plugging in 9 for B. So on the side right here, let's look at angle Q. Angle Q is 10 times 9 minus 16, which is 90 minus 16, which becomes 74 degrees. And then, sorry, not angle P, angle R is 9B plus 25. So that is 9 times 9 plus 25, which becomes 81 plus 25, and 81 plus 25 is 106 degrees. So notice that these two angles are not congruent to each other. This one is 74 and this one is 106, but these two are supplementary. So if you add up 74 plus 106, so 106 plus 74, we end up getting 180 degrees. So this proves that this is a parallelogram. So next, for problem number 3, this is based off theorem 4, which talks about diagonals. Remember that the diagonals bisect each other, and because diagonals bisect each other, that means that each piece of the diagonal will equal each other. So what we need to do is we need to check the length of Jn, NL, Mn, and Nk. So let's start with Jn. Jn is 2x plus 2, but x is 6. So 2 times 6 plus 2 is 12 plus 2, which is 14. Next, let's try NL, and that is 4x minus 10. So what we're going to be doing is 4 times 6 minus 10, which is 24 minus 10, which is 14. So NL is 14. Next, we're going to try MN. MN is 6y plus 1, but y is 3.5, so 6 times 3.5 plus 1. So what is 6 times 3.5? I get 21. So this becomes 21 plus 1, which is 22. So that's Mn. And the last thing we need to check is Nk. So Nk is equal to 8y minus 6, so 8 times 3.5 minus 6. And 8 times 3.5 is 28. So 28 minus 6, and that is 22. So notice that each piece is congruent to each other. So Jn and NL are congruent, and Mn and Nk are congruent. And that from theorem 4, that defines that this is a parallelogram. So that pretty much wraps up lesson 9.2. Make sure to try the homework problems. So here is the lesson 9.2 homework. And if you do not have a packet, try your best in writing the question and answer for each problem on a separate sheet of paper, including the lesson checkpoint. And then when you finished those assignments, you're going to upload those pictures of these assignments to Google Classroom. Thank you. Bye.